All right, you want to see something kind of cool? Take a look at this. Bring it up on this monitor. This round circle here represents a cell built from scratch. It's a one of a kind. And get this, it can feed, grow, and replicate like a natural cell. What do you think about that? The scientists who built it call it a spud cell. And so we're joined now by a lead scientist now, Kate Adamala. She's the University of Minnesota professor, co-founder of Biotic. She says this is just the beginning. I guess, Kate, my question is just the beginning for what? For viewers who've never heard of this, how would you describe this spud cell to them?
Hi, thanks for having me. The spud cell is on the kind of a macro level, just like a natural cell. It has a membrane, and then inside it, it has genes and it has metabolism. The biggest difference between that and any other cell that we know of is that this one can be engineered. It's fully engineerable because we know exactly what goes in it. It has all the components known and defined. And that's not something you can say about any natural cell. So if you want to make things with biology, make different chemicals, different materials, compounds, it's much easier to convince the artificial cell to do that because we know exactly how to talk to it. We know how to engineer it.
Wow, it's pretty fascinating. So you contrast that with a human cell that sometimes goes rogue, gets a mind of its own, maybe even turns cancerous. You're saying that this cell follows the commands of the creator, but I can imagine there could be a dark side to that as well. What are the upsides and the downsides?
The upside is that we have a full control over it. I don't like the word creator because I didn't create something new from scratch. What we did is we put together molecules and they behave like molecules are paid to behave. They're doing all the natural things. So we didn't create something new, completely new to nature. We're imitating nature, we're learning from it, and we're building on it. And the possible downside, like with every cutting edge technology, there could be, we call it dual use technology. There could be potential for misuse, and we're guarding against it by putting switches inside that cell. So it cannot escape the lab. It cannot live on its own. It cannot survive on its own in the environment.
Wow, it sounds like the stuff of Hollywood movies. So worst case scenario, say the switch fails, then what?
Then the thing dies in the environment because it's engineered from scratch. It's very wimpy. It doesn't have the ability to defend itself, to protect itself like natural cells. So if you release that thing into the environment, the first bacteria that's going to come across it is just going to eat it.
Got it. Pretty fascinating. What do you see the future, the next 5-10 years of this?
In the next 5 years, we're going to make it more robust, better. Right now, it's very sheltered. It can only replicate, it can only grow in the lab under very controlled conditions. We want to make it stronger and more robust so we can build bioeconomy on it. We can build it to make products, different chemicals, different drugs, even materials, and make it in a way that's better than natural biology. So expand on natural biology. That's going to help us move away from this petrochemical-based economy where everything we get comes from oil. And, because of oil, I just saw you had a segment on heat waves.
Mm-hmm.
That's part of this big problem of our society relying on petrochemicals. We can change that, and we have to change that. And in order to change that, we have to learn how to make all those chemicals we need as a society using biology. And that's what this technology is going to do.
Kate, I think it's fascinating, and I also just have to say thank you. I'm a dad to a girl age 14 who all the time hears from me, STEM careers, women in science. It's nice to see you there at the helm of such an amazing cutting-edge technology. We appreciate you so much. Have a good day. We'll be tracking this.